All right. Well, it's a great pleasure to be here to talk to a group of developers. Couldn't find a better place to be to share my thoughts and my knowledge with people who share the same passion as I do. So thank you for being here. I want to talk about some things that we get into. One of the things we have seen over the past several years is this sheer adoption of technologies. Java itself has gone through quite a revolution in terms of how we start programming in the language. So I want to spend the next about an hour or so talking about a few things that we can help ourselves to get better at what we do. Well, I travel quite a bit, and as I travel around the world, I get to meet different people. Well, I'll share with you a little experience. Recently on a flight, I had a guy sitting next to me, and he asked me what I do for a living. And I said, I'm a programmer. And he said, that's the easiest job on earth. I said, well, I'm glad somebody thinks of that. And I said, why do you think that's the easiest job on earth? He said, because all you have to know is zeros and ones. That's it. And I said, well, you're right about it, but do you know why they pay us the big price to do this? He said, why? And I said, because we have to figure out in what order to put the ones and zeros. So it's a very exciting experience to be a programmer. I really enjoy the programming aspects. But one of the things I really enjoy in programming is, after all, not what I really started programming for. So what drew me into programming was the math and science in programming. But after several decades of programming, I'm still a programmer. And the reason for that is, it's not the math and science in programming as much, but it's the art in programming. And the way that we can actually express our ideas, express our code, and so many different ways that we can do it is pretty exciting. So when I look at languages, when I look at concepts, when I look at algorithms, I really want to enjoy about the aspects they provide for us beyond what may appear in the very first sight. So I want to start talking about the first thing that we all really get towards when we look at something or interact with something. It is the interface. Languages have interfaces too, and interfaces that languages provide for us is often what we call as a syntax. But I want to talk today about why we should get past the syntax and why the real scare really is in the semantics. So let's talk about interfaces. Well, we often interact with interfaces, but I'm a guy who constantly thinks about programming. That's what I do almost every minute I'm awake. Well, I was in Washington, D.C. a couple of weeks ago, and I wanted to take a shower, and I got into the bathtub, and the very first thing I saw when I got into the bathtub was this one. And I couldn't take any shower anymore, because I looked at this and I said to myself, well, here is a shower, and there is this words written around the shower. And immediately, instead of showering, I had to take a photo and tweet about it. And my tweet was, those who cannot design are condemned to document. And this is a very simple shower. All you have to do is get in and take a shower, but now you have to read a documentation on how to use the shower head, how to turn on the shower. So the point is, when things are not intuitive, it becomes very frustrating. And when we design things, we have to really take the time to make things intuitive for others to use. Otherwise, everybody begins to suffer. And so if we cannot design properly, then we waste our time and effort documenting stuff over and over. This comes to various things we do, including languages as well. So when it comes to syntax, no wonder we often begin to complain about syntax. But what I want to think about is, a syntax is an interface that the language affords for us to program in, and we often tend to really look at interfaces. But one thing we need to keep in mind is the perspectives we have about things around us, the context we often develop with. Well, one of the things that languages have to think about is to avoid this thing called surprises, or the so-called principles of least prices. So oftentimes we want to make sure we don't surprise users, surprise programmers who are the users of languages, and that is something we have to really struggle to keep up with. But we need to keep in mind the perception. What do we perceive things as when we look at it? Well, if I were to ask you what you see here, well, different people in the room are probably going to see different things. Some of us probably are going to see this beautiful vase here right in the middle, or others may actually see two beautiful couples trying to kiss each other. Well, both of them are actually right. It's a perspective, and sometimes you may have to really, really focus on it to look at one versus the other. But this also emphasizes that when multiple people look at things, we are not going to be seeing the same thing, even though we may all be looking at the same thing. So our perception is often limited or influenced by what we are familiar with. Sometimes it may be a temporal familiarity than a permanent familiarity as well. Well, recently I was giving a talk, and I showed this particular code. And I had people in the room, and after the talk, people in the room came to me and they wanted to tell me what that code looked like. And I was quite shocked by what I heard people say. One person came to me and said, that code looks like Scala. Another person came to me and said, that code looks like Groovy. And yet another person came to me and said, that looks like D3. And I said, what the heck is D3? And this person said, that's a JavaScript library. And why would a library look like a language syntax, right? Well, he said, because that's all I've been using lately. So a lot of times what we know, and this is one of the things we do as human beings, is we immediately relate to what we already know or what we are familiar with, because our mind immediately starts to associate with what we already know, and it then starts drawing inferences based on that. So oftentimes, the less we know or the limited we know, it becomes very restrictive as to what new things we can actually pick up. The more diverse things we actually know, it becomes a lot more easier for us to grasp things as well over time. But when it comes to these, limitations are something really fascinating. I'm going to put up a little picture here, and I could ask you what this is, and of course it depends on what language you speak to know what that particular thing is. Well, this, of course, if you look at this, this is a really nice vegetable. And you could ask what this is. Well, the Americans call this one as eggplant. Now, you look at this and say, eggplant, what has got to do with the eggplant, especially being a vegetable? Well, yeah, they call it an eggplant. Well, you may look at this and say, that was one really good imagination to call it an eggplant, right? Well, the reason actually they call it an eggplant actually is that a variety of eggplants look like goose eggs. So somebody looked at this and said, hey, those kind of look like eggplant eggs, so we'll call it an eggplant. Well, clearly, this does not look anything like an egg at all, but it still got the name called eggplant. Well, but what's fascinating to me is that's called an eggplant, but what would you call it? It depends on the language you are speaking. You could call it different things. But I was in Belgium having dinner with people from different countries, and there was one person from the UK, and he kind of made a little joke, and he said, it's kind of really odd that Americans call this an eggplant. I said, yeah, that's kind of funny too. It's called an eggplant. It's surprising they call a brinjal as an eggplant. And he said, what did he call it? I said, brinjal, of course. And he said, what the heck is brinjal? And I said, of course, brinjal is the name of this in English. He said, I'm English, and I don't know what you're talking about. And I was really confused. I said, well, what do you call it then? He said, we call it aubergine. And then I was very confused, so I had to email my uncle who was a professor of English, and I said, okay, I call this brinjal, and the English guy says brinjal is not the English name. What in the world is going on? Well, then my uncle wrote back saying, well, actually, aubergine is the name in English, but we call it as brinjal, and it turned out, doing a little research, we found that brinjal actually is a name from Portuguese. Well, India was ruled by various different, countries, and of course, predominantly, India was ruled by the British, but of course, there was French, there was, Portuguese also occupied quite a bit of part of India, and it turned out the word brinjal came from Portuguese. And I started looking at a little further into it, and I realized that finally Portuguese name brinjal came from actually a name from the Middle East, and Arabic words, and then eventually the surprise was the original origin of this particular word was from Sanskrit. And this was a complete circuit back to where it originated from, and this was really fascinating for me. And it's the same thing, but we all use different names for different things, but we quickly associate with what we are familiar with, and an entire nation thinks that brinjal is actually an English word when it's not even an English word, and it's pretty surprising to see all these things. So things get really interesting once we go beyond what we look at, obviously, and start digging a little deeper into where did things come from. And more important, what do they really mean? And so it's very fascinating when we can go beyond what's really the obvious. But when it comes to programming languages, though, what really hits us first is the syntax of languages. And it doesn't spare anybody. I program in about 12 different languages fairly well, and I have to tell you that every single language I program in, I always kick and scream and complain about the syntax because the syntax is really hard to get through. But if we put in the effort to really get through the syntax, there is so much fun ahead of us to play with. So I want to first talk about a few things that we can think about when it comes to learning different languages, how we can cope up with it. So I've never learned a language where the syntax did not really take effort to pick up in the beginning. But even the best among the people that you know would often be irritated by the syntax. Here is the words from Michael Feathers. He says, first glance, I usually hate the syntax of new languages, especially when they are C-derived with pointless syntax variations. Start fresh. So he's calling out for languages to really set apart the syntaxes of C-like languages and to really try new syntax and new forms of expression. But this can be very frustrating. So I decided to kind of search on Twitter for people complaining about syntaxes. And here's what I found. And here's a quote from a gentleman who says, Ruby is an awful language. I hate natural language syntax as I'm looking at to Apple script. So he's complaining about Ruby. And I thought about this and I said, you know, when it comes to languages, there are so many languages, so beautiful. And the beauty is very rarely actually in the syntax of the language. So talking about Ruby, I really like Ruby a lot for a few different reasons. And one of the things that I really like about Ruby is that new is actually polymorphic. If you really think about Java for a minute, Java or C# or C++, languages like that, think of the word new. New is actually a keyword. And new is not polymorphic. And we have a slew of design patterns called abstract factories and factory methods. And what do these factories do? All that these factories do is really try to compensate for what the language is actually missing, where if the new had been polymorphic, we wouldn't need all these factories after all. So when you think about this, in terms of language design, you can think about it slightly a little differently, if you will. For example, let's say I have a class called book over here, and I want to really say create a function here called, let's call it as a create function. And this create function can receive a class essentially as a parameter. And I can simply say class.new and return a class. So you can see in this case, I can simply say create a book. I can simply pass this and start creating objects of these very easily. Well, clearly in this case, I'm using a new, but the word new is utterly polymorphic in languages like this. So for example, if I were to have yet another class, let's say, in this case, let's say I have a class called, well, whatever we want to call it as, let's say desk, and I want to create an object of that, I can simply use the same thing and say, create me a desk, please, and I don't have to really go through enormous amount of factories to play with it. Life becomes a lot easier to work with. And so to me, I don't care as much about syntax because syntax comes from really practicing. But if you start enjoying some of the semantics languages provide, it becomes pretty intriguing after that. So in that regard, one of the other things that fascinates me in language like Ruby is that the fields actually are pretty darn dynamic. So what that really means is, let's say for a minute in this case, I want to say how many pages this book really has for a minute. Well, how do I tell it how many pages the book has? I could say, for example, pages right here, and I could create a book. So I could say book equals, let's say, book.new, and I want to say in this case, let's say, inspect the book and see what it contains. Notice at this point, the book doesn't have a whole lot right now. But I can then say let's say, pages equals, say, 200 pages. Now I can say book.inspect. And this is pretty fascinating for me because if you notice, the object did not have a field called pages just a second ago, and suddenly that very object now has a field called pages. And what this tells you is that no two objects of the class have to be the same in the beginning, and objects can dynamically acquire fields along the way. And to me, that was very intriguing coming from the background of C++, C Sharp, and Java-like languages where things are fairly rigid and well-defined in the beginning, and it's very difficult to vary it, here's a language that is extremely flexible and saying, I can be dynamic about what objects can include as time goes on, and that is very rewarding to see how flexible that could be, for example. So that gives you an idea about how that can be very powerful. Then comes along expressions. In fact, if you really think about it, what do you think of the words like class, the words like public, the words like new, the words like so many other words? In Java, these are called keywords. I really am not a fan of keywords. And the reason I'm not a fan of keywords is languages with keywords are like mafia. They take stuff away from you and threaten to kill you if you ever use them. So in the case of Java, for example, when they were evolving Java, they wanted to introduce a new syntax for the for each. Ideally, it would have been something like for int element in, let's say, values, and then you could have written something like this. Well, they couldn't do this. Why? Because the word in, well, in was not part of the language already. They did a quick search and they found out that people actually are using in as variables in code. And if they started using in as a variable, that would break compatibility with a lot of code. So they decided to go ahead and use a colon. And even though that is not very readable, the language had to do it. Why? Because that would have become a keyword in the language, and you can't use keywords in other contexts. Well, language like Ruby doesn't have this concept of keywords in that sense. Everything is an expression in a language like Ruby. So as a result, you can say class book right here, for example, but I can take the class and I can treat it as an expression. I can do a puts on it, and what does that return to us? Whatever the code is going to return, that's going to return it for you. So you can see in this case, you can actually take the class itself as an expression. Public becomes an expression. Class becomes an expression. Almost anything you have in the language becomes an expression, which you can also override and redefine. And languages can give you quite a bit of flexibility along the way as well. So when I start looking at languages like Ruby, for example, I quickly go beyond the syntax and I really begin to appreciate the semantics of the language, and it's very fascinating. But that's just not limited to Ruby alone, for example. Here is another thing I saw. I hate to say this, but Clojure seems to have a bizarre confluence of beautiful semantics and ugly syntax, which reminds me of Perl. That's a pretty high insult to even compare with Perl, after all. But if you really think about it, Clojure is another language I really like a lot because of the amazing conciseness that Clojure has, but in addition to it, some of the beautiful things we can do with Clojure. For example, one of the things that gives me a lot of delight in Clojure is the amount of code I have to write or not write, actually. And I don't think I've programmed in another language where the code actually becomes so concise that I often write Clojure code and I have to take a pause and just admire at the code, the beauty of the language in terms of how really concisely we can express things. But one thing that really catches my attention in Clojure is the immutability that's baked into the language. So for example, if I were to look at something like Clojure for a minute, what if I were to create a variable, let's call it as a max for a minute. So I'm going to say define max is 100 over here. And in this case, I'm going to say, I want to print the value. Let's say I'm going to just go ahead and print this particular value of max. Well, that's great, but you can ask me to go ahead and let's call it as max value. And I want to really go ahead and change the value, let's say, of max value. Well, I'm sorry, but there is no syntax in the language to modify a variable once you create it. Clojure treats everything as immutable variables. Well, that's because in functional programming, we don't deal with mutability like we deal with mutability in Java. Well, the reason for that, of course, is when we deal with mutability, the code becomes hard to explain, the code becomes hard to understand, and often it becomes error-prone as well, so we try to really deal with mutability as less as possible. But one thing that really fascinates about Clojure is the very nice way it deals with mutability in terms of the control it provides. So, for example, if you think about Java for a minute, what do you normally do? You create a variable that's mutable. Well, that's great so far, but when you create multiple threads may start accessing this variable. So you're saying, oh gosh, I got to protect this. I want to make sure multiple variables don't change this variable. So what do? You start synchronizing on the variable. Well, when you start synchronizing on the variable, what happens? Well, what if you forget to synchronize, or you synchronize on a wrong variable? Well, the code doesn't give you any error after all, and that becomes really painful and problematic over time. What Clojure does is, Clojure says, I'm going to take every single variable, and I'm going to make it immutable, and that's basically called as the state. But then what about the identity of the object? So Clojure right off the bat provides what's called a separation of state from identity. In a way, if you really think about it, if you look at the human politics and civilization, one of the revolutions of the Western world was the so-called separation of church from state. And in a way, separation of church from state gave us so much more freedom than when the state and the church were tied together. You can think about this as revolutionary as separation of church from state. This is separation of state from identity. So the idea behind this is, I've got a value on my hand, but the value is immutable, but I have an identity that refers to this particular value. I cannot change the value, but I can create a copy of the value, a new value, and in a flip of a switch, I can point to the new value, and the identity can be changed. Well, now you don't have to worry about the concurrency of the state itself, because the state is immutable, but what can you do about the concurrency of the identity itself? Well, that's where Clojure says identities are not just random identities. These actually are often called as managed mutable identities. So what a managed mutable identity is, it is a mutable variable, but it's a very managed object. You cannot just randomly walk up to these objects and change them. You have to follow a certain rules to change it. So for example, in this case, I can change the max value that's been given here, but I'm going to go ahead and put this into a ref object right here. And you can see at this time when I run this, the object actually is a ref object that I have on my hand. And you can see that I cannot mutate this particular variable at this time. But what if I tried to mutate this variable? Well, first of all, let's get the value out of it. I'm dereferencing the value to get the value out of it, but I want to change it. So I'm going to say ref set, max value is, let's say, 1,000, for example. Well, when I try to do this, I immediately get a stern error at one time, and the error tells me illegal state exception, no transaction running. So what that really means is, I tried to mutate a managed mutable variable, and it gives me a slap on my hand and says, how dare you touch this variable? It's a managed object, you haven't got into a transaction. So the language says, well, when a variable is mutable, and I'm going to manage the mutability of the variable, and uncontrolled change to this variable is extremely dangerous, so I'm not going to let you change it unless you enter into a transaction. Well, that begs the question, what is a transaction? Well, multiple threads running concurrently enter into a transaction, and as a result, the changes to these variables are closely kept track by the transaction, and if one variable were to be modified and committed to the memory, all the other transactions automatically roll back and are retried for you at the language level. This is an extremely powerful semantics, all that tied into that little bit of a syntax that you see in front of you. So what I can do to get around this is, I can say do sync over here, and then call this function, and you can see there is no more error, because what we did at this point is we asked it to say, I want you to enter into a transaction and safely modify this identity, and you can see the language already provides this. But the beauty of this is not limited to Clojure. The minute you understand what Clojure is doing with this, if you start digging into this and look at what they have actually done, you will realize that ref and do sync actually were implemented in Java, and you can start using this from the Java code as well. All you have to do is just include closure.jar into your package class path, and you have this available from Java as well. And so when we get past the syntax and look into what the language actually provides, this becomes extremely powerful in terms of what we can do with it, and we can just start benefiting from things like this. So, but we have to, of course, talk about JavaScript. So without talking about JavaScript, we can't take anything for granted. But what about JavaScript? Let me ask you the question, how many of you program in JavaScript? Almost everybody's hand. How many of you like programming in JavaScript? Very few hands actually stay up, right? So those who are raising, they kind of reluctantly raise, and they look around actually to see who else is watching them. I feel your pain. Well, why is that we all program in JavaScript, but very few of us actually like programming in it? Well, I know the exact reason for it. Well, JavaScript itself is very special in a lot of different ways. Well, Brendan Eich, when he was interviewed, he said he never thought people will actually begin to use JavaScript so widely. And I was thinking, how would I describe JavaScript to somebody who says, what is JavaScript? And the best description I could think of is this. JavaScript is like this villain in a bad movie. They keep killing him, but he keeps coming back to life. So that's the way it feels about JavaScript. So JavaScript seems to be this unbelievable power behind this language, and we keep seeing it. But JavaScript itself is extremely powerful. However, JavaScript also has quite a few things that can make things very scary for us. For example, let's say we are programming in JavaScript. You are trying to reason through certain things. And I want to say in here, let's say a equals 1. Okay, that's great. I have a little variable called a, whose value is 1. I'm going to define a b equals 1 as well. So clearly I'm going to say, print the value of b, that's a 1. Well, I could ask this one, is a equal to b? And you can clearly see in this case, it says true. I can now ask him, if I define a variable c, which is 1.0, and the next question I'm going to ask it is, define if b is equal to c, and JavaScript says, sure, why not? That's absolutely logical. But then I'm going to ask JavaScript, is a equal to c? Well, you see, in math, of course, we have this thing called transitivity. If a is equal to b and b equal to c, it's only logical that a equal to c. But if you ask JavaScript what it thinks about it, it says false. Well, you may look at this and say, that's not logical. Let me remind you, you never use the word logic and JavaScript on the same sentence, right? So if you ever show this to your children, they would never take after our profession, right? They would look at this and say, this is some kind of a voodoo. I'm not going to be practicing this, and they will run away. So this is disastrous. This is one of the most powerful languages of the world where the semantics is completely broken. And you can imagine how miserable life is when you start programming with this. So when people complain about JavaScript, it's not a problem of syntax that we are enduring. It's a problem of semantics. In fact, the beauty of this is, I saw this the other day on Twitter, and I couldn't stop laughing. This guy had 2 books on his table. This one is Java, the good parts. This is the JavaScript manual. And what this tells you is, this is all the things you can do with the language. This is what you should really do with the language, right? And in fact, when Douglas Crockford wrote this book, he called it the JavaScript good parts, but that book actually is pretty interesting when you start reading it. It's about 96 pages long, but the truth is, he's got 4 pages in the book that says what to do, and 92 pages where he says, don't do this. So this book was actually 4 pages long, and O'Reilly said we can't publish 4 pages. So he had to pad it with the other stuff to get it published. So this language is amazing because there's only so much you should be really doing with it, and everything else is full of crap. So the point really is we have to be very careful about how we use language as semantics matters. But I want to say one thing though. Do you know why you have so much trouble with JavaScript. I'm sure you have thought about this one day and you said, man, why am I having so much trouble? Why am I not liking JavaScript? Have you ever thought about this? I have a reason why that is. And the reason is, if you ever try to use JavaScript, you'll be disappointed. And the reason is very simple, that when you deal with this language, there's something you have to realize, and realizing this makes life a lot better. You don't choose JavaScript, it chooses you. So never feel bad about it. So if it is not for you, just remember you are not the chosen, right? So JavaScript actually has to choose you for you to get really comfortable with it. And that is one of the frustrations we go through in this language, is it gets very frustrating when you start dealing with this language, and be just happy that you can use this language. So given this, I want to then talk about other languages, of course, that we all keep hearing about. And one of those languages, of course, is Scala. Well, I've written books on Scala. I really like Scala a lot. And I actually enjoy programming in Scala for some really, really good reasons as well. But I always keep hearing about complaints about the language as well. But why so? Well, here's one thing that I came across. Jessica talks about somebody else who is mentioning this. Scala is the only language that the more I learned, the harder it got. Well, I tweeted about this, my own views, a few years ago, and my statement is, Scala is like the sea. We can choose to sink in its complexity or develop skill and patience to really sail for fun and productivity. So in a lot of ways, if I ask you, is Kyiv a really wonderful city? You're going to tell me it really is, and I don't have a reason to not believe you. I've been here quite a few times. I really enjoy the city. However, you would also pull me aside and you would say, hey, Venkat, it's a really nice city, but there are parts of the city you shouldn't go to. Well, Scala is kind of like that. You can be very comfortable going through it, but there are very dark parts you should never go into. So when you hear people complain, they have been mugged in those bad parts. And they say, this is a really bad place. Well, it's not. You just shouldn't go to certain places. The language has a lot of power, but some languages really are not meant to be for a lot of us to really use. And we have to really, be there to use the right strengths of the language rather than be dragged into it. So in that regard, here's one tweet I saw. There are days when I truly hate Scala syntax. Well, Chris actually goes into a little bit more detail, but I'll come back to that. But before I do that, I want to talk about this. He says, there are days when I really hate Scala syntax. But again, I find Scala to be extremely concise. Let's think about conciseness for a minute and see what it can really mean to us. So let's go back here to Scala for a minute. Let's say we are interested in looking at what Scala can do, but let me ask you this question. Everybody here is familiar with Java. Most of you are programming in Java. But let me ask the question, have you ever, maybe informally, have you ever tried to teach somebody Java? Have you done that? Oh, we have quite a few of us. So you wanted to teach somebody Java, maybe a friend, maybe a cousin, and they said, can you teach me Java? You said, yeah, sure, Java is cool, I can teach you. And they are really, really nervous. They say, is Java really hard? You say, no, Java is simple, because every book says Java is simple. They're like, really great, I want to really learn, but don't go into complexity, just start teaching something simple. You said, why don't I teach you Hello World? And they're like, that's awesome, I want to learn Hello World. So you said, let me show you how to write Hello World. And what did you do? You said, first thing, public. Excuse me, what is public? You don't need to know that right now. Okay, public, no need to know that right now. Okay, what's next? Class, excuse me, what's a class? You don't need to know that right now. Okay, class, no need to know that right now. And then you said, hello world. And the person is like, I love it. And then you said a little curly. They're like, what now? Aren't we done? No, we got some more. And what did you say? Public. And they're like, about to ask the question. They look at the notes. No need to know that right now. That's okay, I'll be quiet. And then you said static, and that's it. You just drove them crazy, right? They looked and said, excuse me, is that also something I don't need to know right now? They don't even know what's coming ahead, like main after this, right? And halfway through, they're slipping out of the chair, and they're like, excuse me, this is not for me, right? Well, where's simplicity here? That's not the word simple. There's a name for it. It's called ceremony. So what is ceremony? Ceremony is what you have to do before you get to do what you really want to do. Anybody here who likes ceremony? No, because ceremony beats you down, right? And takes the life out of you. And when you're done with all that, you're like, why did I even come here, right? What am I supposed to do? So it's ceremony that drags you in, beats you down, and then you're like, what am I trying to do? So to me, programming is a series of light bulb moments. So if you ask me, what is coding, Venkat? Coding is where I am sitting and writing stuff, and suddenly I got an inspiration. I'm like, wouldn't this be cool to do? And the minute you have that cool thing in your mind, you want to get some code running so you can go talk about it, get permission to go further into it. But when you're dealing with ceremony, what does it do? You got this really bright idea, like, wouldn't this be great? And then you look at the code like, never mind, not today, right? I'm not going to waste my time writing that code because it drains you down. Well, what does Scala say? Scala says, you want to write hello world, write hello world, right? So I can say hello world and be done with it. I don't have to write a lot of code to get something really simple moving. Not only that, we can also do some other things really cool with the language. Well, one of them is working with XML. For example, let's say greet equals, and then I'm going to say greet over here, hello, and I'm going to say greet right here. And once I create this, I want to go ahead and print out greet. Now, in this case, of course, I've written an XML. Well, but did I really write XML? We all have done this. We all write XML, but what do we normally do? We put that into a string. Now, how many of us have written XML in a string? Almost all of us are guilty of that. And what will XML do? If you are put in a string every time, how will you feel, right? And no wonder XML feels really bad and misbehaves. So XML is like, I don't have freedom. I'm always within the stupid string. Well, Scala says XML deserves just a little bit of respect. Not a whole lot, but just a little bit. So you can see in this case, I don't need to put into a string. XML is a first-class citizen. You can create XML content, and XML can be processed at the language level. And so semantically, XML is a construct that can be used in language various places. But then one of the other things that really draws me into a language like Scala is an unbelievable power behind pattern matching. Now, pattern matching, for example, is I can do something like this. I can define a function process, in this case, and the process function says, take me a message, any message you give it to me. And I'm going to say, in this case, something like message match, and I can start matching against the message. For example, in this case, let's say I'm going to take an integer value. So I could say some value x is an integer. I can simply say got and then maybe the value of x. Well, in this case, as you can see right here, I can specify that I got a value of x that I want to print out. Well, clearly, I can start printing the values that I got on my hand. So I can call process in this case and say a value of 5, for example. Well, in this case, of course, a case. So I can start passing values into this and start processing them very easily. However, I can call process and pass greet to it. A bit scary, though. But notice what I can do. I can come now here and say case, and I'm going to say here's a greet that I have on my hand. But I want to grab right off the middle a little, message, right? Say whatever is the, message, we'll call it message. And I can simply print out, in this case, the message you gave me, and I can now start passing and parsing it without having to use extensive parsers, if you will. So you can start beginning to see the power the language affords you in terms of just taking on to a pattern and matching it. And wouldn't it be so cool to have this kind of capability where we can start processing these things very effectively? I would need a lot more than 15 minutes just for your record. So I'm not going to stop in 15 minutes, so ignore the time. So the point really is, we really want to be able to have these kinds of capabilities on our hands to really be able to leverage these power. So we definitely have to be able to process these things very clearly. So the idea behind this is we can start leveraging the language powers in terms of the semantics once we start really looking beyond the syntax of the language and where it can take us. So given this, actually Chris goes to the next level and he really addresses the issue here. His tweet actually was not complete when I showed you. He actually says, Or more correctly, I hate that I can't easily unwire my own Java C syntax comfort zone. And I think that really is the bottom line we have to be very careful about. So one of the problems most of us have is not really the syntax, but it's really about our familiarity with what we are really good at. And the more we are good at something, the really suckish we are in something else that we are not good at. And so it's important for us to diversify what we know. That becomes extremely important. So one of the key things to think about here is to get out of that comfort zone, because when we are very young programmers, maybe we don't know a whole lot, and maybe this is your first job. What do you do at those times? You're willing to try things. You're willing to experiment. You're willing to take on a lot of risk. And a few years later, you gain the experience, and what are you then doing? You're comfortably sitting in a chair, and a few years of experience later, you're comfortably laying down on a sofa. And now you're saying, this feels really good, don't bother me anymore. I come to work, I know exactly what I'm doing, I don't have to think a whole lot. And anytime somebody suggests doing something a little different, we're not too happy anymore after that point. So one of the things that happens when we become very experienced is we tend to really develop this comfort into this comfort zone. What if every single day of our life we will spend a few minutes where we're going to be very, very uncomfortable? What if we're going to do something that we really are not good at? And then, of course, our mind really starts orienting towards learning something very different. In a way, this is something we need to think about. As human beings, as a physical health, if all I do is sit on a couch, eat potato chips, and watch TV for 6 hours like a lot of people do, and you come along and say, hey, Venkat, do you want to go for a jog? I'm going to laugh and say, go for a jog. Why don't you jog twice the distance for me as well? And while you're going out the door, grab another chips and drink for me before you leave. My muscles are going to be so weak that I can't really physically exercise any more than getting around the room. Well, but if I start really, maybe a little bit at a step at a time, maybe a little walk one day, a few weeks later, maybe a little jog, then I become a little bit more fit. Well, then, of course, the minute you call me for a jog, I'm going to be up and running for it. Well, the mental mind is exactly the same. The mental mind develops fatigue over time, and it becomes so stuck in the way we do things. Anytime you throw something different, the mind says, sit back, don't move, it's very comfortable here. So just like we exercise physically every day, or we should exercise physically every day, we should also take a few minutes every day to give the mental exercise. I'm a huge fan of lunchtime activities. When I used to work for a company where I was employed, lunchtime was my time. That was very precious for me. I'll be doing the coding during the day, but the minute the lunchtime is on, I would grab a book or an article or a tool, and I would spend the hour literally eating in front of the computer, but trying something completely different, totally unrelated to my work, so that my mind can exercise to do something completely different out of the ordinary. And most of the time, within a year or two, I was using some of those things in other activities and other jobs. And of course, some of us get that by going home in the evenings and working on projects as well. But we have to really make that part of our daily activity. That becomes extremely important. So one of the lessons I've taken over time is don't really get bothered by the syntax. Instead, learn the semantics and practice the syntax. I've never ever been able to read and understand and remember the syntax. The only way I ever remember the syntax is by practicing writing code on the language. So these days when I pick up a new language, I completely brush aside the syntax. I don't even pay attention to it. I get directly to the semantics. I get directly to what do these things really mean, and I focus on the idioms of the language. Idioms of the language is where the real fun is as well, because somebody who is familiar with the language writes code in the language very differently than somebody who has no clue about this language at all. So this is something we have to really try hard to do when it comes to learning a different language or learning the language itself as the language evolves. Because for example, if you look at Java itself, Java has evolved to accommodate functional style. Now you may ask, how much time does it take to really learn the functional style of Java? Well, if you had been only programming in Java exclusively, it's going to take more effort to learn Java 8 compared to Java 7. But if you had been looking at other languages around there, then it becomes a lot shorter to pick up the things in Java 8 because Java 8 has really brought what other languages have had for a while into the language. Differences are in the syntax, not as much in the semantics itself with these other languages. So a true appreciation or understanding of the language emerges when we really dig into the semantics of the language and not just its syntax itself. So that's why we really need to start thinking about and focusing on the semantics of the language. Let's talk about this a little bit further. So let's dig into the semantics. Well, one of the favorites, everybody's favorite, singleton. Now, if you ask me, what is a singleton pattern? I have a definition of a singleton. Singleton is a pattern that you take 5 minutes to learn and a lifetime to get it right. And it takes so much effort to really get singleton correct. So we all have learned about singleton. So what do? You are going to write a singleton. So the very first thing you do, class my singleton, and you make your constructor private. You make your instance static property, and then you write a method called getInstance, which is a static instance that returns an instance to you. Hey, life is good. I've created a singleton. Well, 2 days goes by, and you got a colleague of yours says, hey, look what I have on my hand. And you see they have 2 instances of the singleton. You're like, damn, how did you do that? Well, I used reflection to call this, and I created 2 instances. You're like, I'll fix it. So what do? Put a little bit more code. If you call this, and if the object has been created already, fail. Well, that goes fine for about 2 weeks. Then another colleague of yours says, look, I've created 2 instances. You're like, how did you do that? Well, I serialized it and deserialized it. Like, damn, I'm going to fix it too. And then 2 weeks goes by. This is the day called bring your kids to work day. And one of your kids' daughter is at work. And she says, look, I created 7 instances of your singleton. You're like, damn, how did you do that? Well, I created 7 threads. Oh, like, how do you win this? More code now. There's a name for this. It's called Scotch tape-driven development. You put a little Scotch tape on it, and then you look at it. Is it going to hold? And then it peels off a little bit. More tape now, right? And singleton is so horrible that the more code you write, the more it breaks over time. So how do you really fix it? Well, Java says there's a nice way to fix singleton, and if you're using Java 5 or later, and you should, what are you going to do? Well, in Java, you could simply say, well, I'm going to create a enum, for example, and then enum singleton, whatever you want to call it, and then I can start putting stuff into the enum. Well, it is a weird world, but an enum is a singleton. Why? Because you are being given the ability for you to create stuff which processes the things the way it's supposed to, and as a result, could I ask you not to show the time for me, please? I get very distracted. So, thank you. So, the point really is, it really loses chain of thought. I'm really sorry. So, you really want to be able to focus on the issues with singletons. So what does that really do? It says, well, you got to take care of construction properly. You got to make sure that you do serialization properly. There are so many slew of things you have to do. Well, all that is done for you by the enums, so why not use the enums? Well, but that's really not a really great way to implement it. Well, Scala says, well, why don't we, for example, say object over here, singleton, and in this case, of course, the object is a singleton pattern implemented in the language level. Well, at the time of creation of the class and the class being loaded into the virtual machine, it can take care of these things for you properly. And again, the languages, the more a language is powerful, the fewer you would need patterns. The less powerful a language is, the more you compensate with patterns around your world, and that's a sign of what we have seen over time, is that it becomes incredibly difficult for you to deal with. So similarly, a topic we could all talk about is checked exceptions. And checked exceptions, of course, there is really not a good answer for it. Is it good or is it bad? And you have a room full of people, you would have a divided world of people in front of you. And this was a good experiment. You could call it as a failed experiment, but it's something that's going to stick with it for a long time, very difficult to get rid of. And what do we do normally? We write code, and in fact, Java programmers have gotten so good at it. How many times you see empty catch blocks in the code? And programmers tell you, I never did this. The IDE did this, right? So IDEs have gotten so clever to put empty catch block, we don't even see it. And that's a nightmare during code review because you see these over and over, and you want to take time to fix it. That again is a semantical problem that emerges in front of you that you have to deal with. But then, of course, we can talk about threading. Now, multi-threading is so much of an accidental complexity when it comes to writing software. So, for example, when it comes to multi-threading, how do we deal with threading? Well, you got variables. What about mutable variables? Well, what about shared mutable variables? Well, it turns out shared mutable variables are really the devil's work. Because the minute you have a shared mutable variable, you're trying to control that variable. Now, what happens if you don't synchronize properly, or you synchronize at the wrong place? It becomes a mess to deal with. And that so much code we write is simply to work around the language limitations and the library limitations. In a way, I would argue, if you are programming it with Java, at the first thought, this looks like a brilliant idea about multi-threading. Here's a tweet I saw which was really very effective in conveying this idea. So when you think of multi-threading, you're thinking, aha, this is so awesome. It is like all these dogs can be fed at the same time. But the minute you start doing this, the reality is it ends up actually being something like this. And then you realize this was not as fun as I thought. Actually, it's worse than this. This is not what the result is. Your job is to clean up after the dogs when this is done. That's when the real fun emerges out of this. So multi-threading begins to become such a hard job to work with over a long time. So if you really think about this, what happens if you synchronize on a wrong variable or you forget to synchronize? Let's think about this. The compiler gives you an error, correct? Is that true? No. Okay, the compiler gives you a warning. Is that true? No. So what does it do then? It quietly compiles your code. And then what happens when you run it? We don't know. You run the code, it works most of the time, and sometimes it doesn't. And then how do you feel about it? You call a colleague and say, look, this is broken. And the colleague says, really? Run it again, show it to me again. Sorry. It works now, right? It becomes extremely frustrating when this happens. And so I've realized over time, doing multi-threaded programming with the JDK is like trying to go on a vacation with the in-laws. It's not as much fun, right? It becomes really painful, and they're going to be complaining endlessly with what you do. The JDK kind of concurrency library is kind of like that. It doesn't give you that capability very well. It becomes really painful. So how do you process list of values? Another thing you can think about. Well, again, when it comes to list, we got problems with list. What about mutability of list? What about iterating through a list? What about iterating through a concurrent list? All these things become painful as well. But one thing we can talk about is imperative style of programming, because most of us have done imperative style of programming for a very long time. But we can do a little bit different, better, at least in most languages, including Java, moving forward. So let's think about one example. Find the total of square root of first n prime numbers starting with k. Let's give it a thought for a minute. So I want to find the prime. So what am I interested in finding? So I'm interested in finding this total of square root of n prime numbers. So numbers, let's say numbers, and starting with, let's say, k. Well, let's write a function. We'll say public static. That's going to be a result of double. We'll say compute. I'm going to give a number, let's say k, and a number n to begin with. Great, so far so good. I want to display the result of it when it is done. So I'm going to call compute. Let's say 100 numbers, starting with 100, and I want to say 51 numbers. Well, that should be really simple to write, isn't it? But how would I go about writing the code for this? Well, after all, I want n prime numbers, and then I want to start with k. Well, we can write a function, first of all, to find if a number is prime. So we can say this is Boolean, is prime, and I'll say here's a number that I want to start with. And in this case, of course, I want to determine if the number is prime. So I'm going to say number is greater than 1. I'm going to show you a functional way we can actually write this. So stream.range. And in this case, I'm going to say, given a number, let's say 2 to the number, And I want to ask it if anything matches on this. I'm going to say dot none match. And in this case, let's say a divisibility. So given a number I, number, let's say, that we have on our hand, mod I is equal to 0. So in this case, we can say if a number is prime or not. Well, I'm using a functional style already here. But what about this function? Let's focus on this for a minute. So how do I go about finding if this number is the result of this? Well, normally we would say int index equals the starting value k. Well, that's great so far. Are we done? No, while, and we're going to say a value that we are interested, index, is less than the value n. Well, stop right there for a minute. What do you normally ask? You stop here and say, is it less than? Or is it less than or equal to? Do you ever ask the question? Every single time. And the day you don't ask it is called the off by one error day. Right? It's very annoying when that happens, right? Well, then what do? Well, then you say, of course, I'm going to start with that value. But of course, I've got an index. But I realize quickly, it's not the index. It's got to be a count. Because you want n values or k values after all. So you're going to say, in this case, int count is equal to 0. Look at the accidental complexity that comes around very quickly. Then you say, if e is prime on the value, what is the value in this case? An index. Well, if it is a prime, what should I do? Oh, of course, I need a result. What did I forget to put? So result is equal to 0. And then what do you do? In this case, of course, result plus equal to math dot square root of index, and then you take the value. Are we done? Well, I want to output the result of this. This is called hope. But before that, of course, I have to increment the index. So let's go ahead and say index plus plus. And you say, wait a minute, you shouldn't increment the index right there. You should increment it outside of the f. But of course, we have to increment the count as well. So count plus plus. And you will tell me, don't increment the count there. You have to do it within the f. Now, think about the complexity of this code that you have to write. And then you write all this code, and when you're done, what do you do before you run it? You stare at it, right? Is this correct? Is this really right? And you feel so embarrassed because it makes you look like a fool, right? And is this correct? What do you think? No? What's wrong with it? Oh, I want to return the value. That's correct. So I want to return it instead of printing it. So return result. So return the result so I can print it outside, right? So great. But let's look through this. I got an index with the initial value. I have a count is less than n. I'm incrementing the count. I've got the index, I increment it. I find the value. And nervously, I could run this and see if it produces the result. And in this case, of course, I need to bring in a stream. So let's bring in the stream. So you can see in this case, we got a little code. And if you look at this code, how does this feel when you write this code? If you show this code to somebody and you say, what does this code do? You can watch their eyes. What do their eyes do? It goes up and down until it settles on this point. That's called the point of confusion, right? And you're staring at this. Does this really do the job? And that can be really frustrating. And if you look at this code, that's a lot of complexity in this code. Now, how does it feel to write that code? And the way it feels is, programming in imperative style feels like you're talking to a toddler. If you have a little toddler, and you talk to a toddler, the first day you talk to a toddler, it feels amazing. You're like, this is so cute. I spoke to this little kid. And then the next day you realize you have to say the same thing again. Walk slowly, don't hold it with both hands, look where you're going, don't step on the cat's tail. And the third day you realize you have to say the same thing. And then you realize this is going to continue for the next 18 years. That's called parenting, right? And so when you start working with code like this, it becomes very frustrating. Let's try this one more time and see how this is going to feel like. So in this case, what I'm going to do is I'm going to simply say, given this collection of streams, so I'm going to say return stream.iterate, and I'm going to ask it to start with a value, in this case k, given an element plus 1. So if you look at this right here, notice what we have on our hand. This one is an iterate function. What does it say? It says, starting with the value k, Give me the next value and the next value and the next value. What is that called? That's called an infinite stream. So the infinite stream says, I'm going to keep on producing more values on demand when you ask me for more values. Well, now that I have an infinite stream on my hand, I'm going to ask it to do a filter operation. So I'm going to say dot filter, and in this case, I'm going to say, give me only the prime values. So we went from an infinite stream of numbers to infinite stream of prime numbers. And then what did we do? I'm going to say, give me only math dot square root of all of those. But then what? Limit me to n values. Notice, I did not say less than n. I did not say less than or equal to n. It's n, damn it. There's no need to think about it, right? So it becomes extremely expressive and easy to convey the idea. And then I'm going to say, in this case, what do I want to do? Perform a sum operation of the values and return it. So you can see in this particular case, I'm able to produce the same result, but with a lot less effort than I did a few minutes ago. And not only that, it's a single pass through the code. I don't have to go back and forth evaluating. It becomes a single pass. You start at the top and you say, get me the collection of these numbers, but only the numbers that are prime, but only numbers that are square root of the primes, total them up, and I want these many values. So the code becomes extremely expressive. So when you write functional code, it feels like you are talking to an adult. But knowing some adults I know, let me restate it, it feels like you're talking to a responsible adult. So when it comes to these code, we want to really write code that is expressive, easier to understand, easier to maintain. One last thing I want to mention is, we do this all the time in programming. We deal with complexity, but what's worse is, we tend to really bring multiple ideas into one. And when you bring multiple ideas into one place, it becomes really hard to maintain the code. Well, with one of the semantical differences we need to really aim for is to separate the separation of concern. Functional code gives us the ability to separate these concerns quite effectively so that we can easily do things with the code. Modify it, evolve it, even parallelize it becomes a lot easier, so we should work towards it. So when it comes to programming languages, syntax is what we begin to see first, but I think we have to go beyond that very quickly. I'll mention one code here by Henry Thoreau, which I think really nails this down. It's not what you look at that matters, it's what you see. So we look at syntax when we look at languages, but we have to really see beyond the syntax, and the idioms and the semantics is where the real fun is, and it's a lot of fun learning through those than being stuck with the syntax. So I hope you'll be able to enjoy the languages and learn their power and then come back and apply them in whatever languages you program in. It's a lot of fun to be going beyond the syntax. So see past the syntax and religious semantics because that's where the real fun is. I hope you found that useful. Thank you.